In today's world, we have a lot of platforms where we can run software on. For example, we have computers, we have tablets, we have smartphones, and all sorts of connected devices, even crazy stuff like refrigerators or toaster machines. And choosing the right developing technology for each of those platforms can be a very complex task. So in this video, we are going to review all the different platforms there are and what's the best technology for each one of those. Let's start by defining what a platform is. A platform is the place where you actually run the software. For example, if you have a mobile application installed on your phone, you have a mobile platform. In this case, the platform is your phone. But if you're accessing, for example, a web page, that's a web platform because it's being executed in someone else's server. That's the magic of the cloud. And you're accessing that web platform via your browser. If you have that software installed on your computer, you have a desktop platform. It's usually called desktop, even though you can run it on laptops or whatever device. But if you have that installed in your computer, let's call it a desktop platform. So there are the basic three platforms we have in today's world. We have mobile platform, we have web platform, and desktop platform. Let's review each one of those. Let's imagine we want to create a social network. So we will have all of the modern features of a social network. We have posts, we can share pictures, we can message our friends, we have group chat, and why not, we have stories or something like that. So first of all, we want our social network to be accessed via the browser. So we want the people to access to socialnetwork.com. When people access that specific address in their browser, they will access a web platform because it will be executed on our server and their computer will actually not run anything. In that case, the platform is just the web. So for this case, for the case of a web platform, we'll have many different technologies. And it's important to differentiate the part where you actually see, that's called usually the front end, and the part that's being executed on the server, that's usually called the backend. For front-end development, we have many technologies, but usually, 99% of the time, you will stumble upon JavaScript. That's the main language for developing front-end. And in JavaScript, you have some stuff called frameworks. Those frameworks are kind of toolkits where you can develop software with. So we have many frameworks. We have, for example, React, we have Vue, we have Angular, and all those frameworks can be used to develop the front end, the part that you will actually see when you access the web page. But the part that will be executed on the server, the backend, will usually use a very different programming languages than the front end. In this case, we have, for example, Python, we have C#, we have Java, we have Go. All of those are programming language specifically created for backend technologies or for being executed in a server. And you can mix all of these technologies. You can choose whatever you want for developing your backend and your frontend. And if you have a good design in your application, it won't matter whether you use, for example, React with Python, or you use React with Java, or you use React with C#. If your design is well done, it won't matter at all. Now let's suppose we want to create a mobile application for social network. So it will have an Android client and an iOS client. If you're going to develop mobile applications, you usually want to create it in one specific language for each platform. So for example, for developing on Android, you have Java and you have Kotlin. You can choose whatever you want, even though Kotlin is more modern and it's usually the best design for today's world. The same with iOS, you can develop with Objective-C or with Swift, and it's very much the same case. You can use whatever you want, but Swift is the most modern language and you can use that one specifically, and it's the recommended way to develop on iOS. Then you can have something called cross-platform, when you use the same technology for developing for both platforms. You can use React Native for it, you can use Xamarin and some other technologies, even though if you have very high performance in your applications, you usually want to create applications with the native language. That's Swift or Kotlin. Now imagine you want people to be able to install your chat client in their computers because you want them to be able to use it while they are working or while they are browsing the web or whatever they are doing. You want them to always be able to access your chat, the chat for your social network. In that case, you will probably want to develop just one application and you want it to be able to be installed in whatever operating system they have. The problem is that operating systems vary quite a lot because, for example, if you have an Apple computer, that will have macOS installed as an operating system. But if you have usually another branding computer, you will have a Windows operating system, and there are very, very different operating systems. So, for example, you can use something called .NET to develop Windows applications, and you can use Objective-C or Swift to develop macOS applications. Even though most modern applications or services are developed using something called cross-platform again, and you have very different technologies in that case. For example, you have something called Electron, where you create something like a web application that instead of being run in someone else's computer or in someone else's server, will be run in your actual computer. That will have some performance issues, but from a developing point of view, it will be way easier to develop with. And since we are storing user information, we will definitely want to have a database to handle that task. In this case, you can have two kinds of databases. You can have relational databases and non-relational databases. For the relational ones, you can use free software as Postgres or MariaDB or MySQL, but you can have very proprietary software that is very reliable as Microsoft SQL Server or Oracle databases. But for NoSQL databases, for non-relational ones, you have a lot more of options because you can actually create your own database engine, but you can use something called Mongo, something use CouchDB, or whatever else you want. But bear in mind that storing user information is a very, very difficult task to do right, because you will have security issues, you will also have performance issues, so you will definitely want an expert to do that part of the job. So let's review where we are right now. We have our web platform, that's our backend running the main business logic. We have the front end that's serving the interface to the users to access to the social network. And we have the database where we actually store the user information that's connected to the backend. Then we have our mobile application that's also connected. It can be to the backend or directly to the database. And we have our desktop client, that's our messaging client, that's also connected to the backend or directly to the database. All of this mess is called infrastructure, and that's a very, very important part of your whole system, because as you can see, you not only have one application, but you have many applications and you have many different software platforms, you have many different requirements for each one of those. So managing the infrastructure in a very efficient manner is something that's very, very complex. That's where you want an IT architecture. Then that's usually their job to handle all of these mess for you.
If you found this video useful, please like, share, and subscribe with notifications on. If you're interested in software development, artificial intelligence, or have a question, please contact us through our website and social networks.